Now that we understand how line coverage works, which is relatively simple, let's move on to something a little bit more complicated. Let's take a look at branch coverage. So in branch coverage, we want to ensure that all branches are covered in the code. So for every decision statement, we need to execute true and false. So in this code, this breaks down to 3 statements: B, C, and F. So let's build a truth table that just looks at these 3. The rows in our truth table correspond to the 3 branching statements that we care about, and the columns correspond to the test cases that we've written already. And in each cell, we'll keep track of whether or not that test case executed the true or false branch for those decisions. So for T1, we can see it's true, 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 and for T2, we can see true, false, false. So here we can see that for decision C and F, we've executed both true and false, but for decision B, we've only executed true, and we need to design a new test case, T3, to execute this case. Looking at the code for decision B, we can see that what we need to do is pass in an opponent that isn't a Mario. All of our test cases have done it this way, so we need to go and add a new test to the pseudocode where 2 enemies, for instance, hit each other. Right, so the pseudocode for this test will look like this: turtle.hit new turtle. These are where 2 turtles are running into each other on the screen. So we go and take a look at the truth table now and see how the code is being executed. We can see false for B, C is actually never reached because we've taken the false branch, and false. And now with these 3 test cases, we have 100% branch coverage. Achieving 100% branch coverage required 1 additional test over 100% line coverage. And that's okay, right? Branch coverage is a more stringent metric than line coverage. But that extra test case was good, right? It helped us to understand that our system executes correctly better than we could with 100% line coverage alone, right? So even though the metrics are both at 100%, the more stringent form of coverage gave us a better assurance that our system executed correctly. Let's take a look at an even more stringent form of flow-dependent coverage that is often used in practice, and this is called path coverage. In path coverage, we need to make sure that we've executed all paths in the code by our test cases. Each path is an ordered set of nodes representing a traversal through the control flow graph. So, going back to our control flow diagram, we know that a path is independent of existing paths if it touches at least one different node than we've seen before. So here's a truth table that shows the 6 paths that represent ways to get through our system, with the test cases that capture each of them on the right. So we can see that 3 of these paths are already covered by our existing test suite. Looking at the path ABFG, we can see that we need to pass in a figure that is not a Mario, but want to return true for dying. It turns out that this is an infeasible path, because if the opponent is not a Mario, being hurt will always be null and F can never be true. So some paths just can't happen in practice. But there are 2 paths here that are both feasible and aren't covered by our existing tests. So first we need a new test case where Mario runs into an enemy and he dies. Right? It's kind of unbelievable that we didn't encounter this before. So the pseudocode for this test would be turtle.hit new Mario with direction right. So here Mario is moving to the right, and we would expect that he'll die at the end of this. Right? So the new path on the diagram for this is ABCEFG. Right? So this is the new path that this test T4 will cover. We also need a new test where Mario jumps on an enemy and the enemy doesn't die. You could think of this happening when Mario encounters a boss in the game. So the pseudocode for this would look like this. Right? Boss.hit new Mario with direction down. So Mario is landing on a boss. So this takes a new path as well. This is ABCDFH. So achieving 100% path coverage required us to write 2 more tests than we even needed for 100% branch coverage. But these did cover 2 important cases, right? Where Mario actually dies when they run into someone, and when Mario encounters a boss. So these were both good tests. Just to recap here, we've built test suites that give us 100% line and statement coverage, and those required 2 tests, T1 and T2. 100% branch coverage, which required T1 and T2 from line coverage, along with a new test, T3, and 100% path coverage, which used T1, T2, and T3 from branch coverage, and added 2 new tests, T4 and T5. From this example, we can really see how moving from a simple type of coverage like line coverage up through branch and path coverage can help us better understand how well we validated our system. Even with 100% path coverage, we're not claiming that this code is error-free. Right? But it helps us to understand how much thought we've put into testing this code so that we can think about its quality going forward.